Okay, cool. Hello. Oh wow, Dan is here with the pizza. It worked out very nicely. Okay. Okay, cool, cool, cool. They gave us an extra pie out of courtesy. That's good. Because they fucked up our order. That was very nice of them. Okay, cool. By a show of hands, who is a freshman? Every single person in the room. Phenomenal content. Okay. By a show of hands, who has ever like built an app before? One person. Who's built like a website before? Like two people. Um, has anyone built like some code that was intended to be used by other people? Cool. Couple of people, couple of people. All right, cool. So, oh, this is the wrong slide. Cool. So like, if that's the case, odds are you've like maybe heard of like Amazon Web Services, like AWS, or like you've heard of the idea of like the cloud, right? Yeah. Cool. So this talk is going to be about that, like pretty vaguely. So before I begin, this is a link to everything that I'm going to be talking about today. I'm going to cover a lot of material, so I just like wrote it up into a document. Someone do me a favor, just go to that, make sure that that link goes where it's supposed to go. It should be a like Word doc or like a Google Drive with like everything that I'm about to mention. It should be titled like Ali Web Services Talk. Uh, Why did you spoil the joke, Shrija? Why are you like this? Okay, cool. If you actually go to that link, it redirects to my Twitter. Follow me on Twitter. I need attention. But moving into the actual presentation. Hello, my name is Ali. There's like some new faces. I'm a junior here at Rutgers. I'm the president of USACS. I am a coach with Major League Hacking. If y'all have ever heard of Major League Hacking, I'm interning at Microsoft this summer, and like I enjoy DevOps. Right? Is that what it says? Yeah, I enjoy DevOps. Okay, cool. So, what is DevOps? By a show of hands, who like has heard the phrase DevOps before? Like a couple of people. So DevOps like basically boils down to not my problem, don't care, didn't ask. Plus I'm a software engineer. So like when you work at a company, right? You will be writing code. But like once you write that code, like it needs to go somewhere, right? So DevOps engineering is like the role where you put the thing where it needs to go. Oftentimes that means putting it up on a server. It means like configuring the environment for that server to make sure that like it works and that like nothing like breaks and that like all of the access is like allowed and whatnot. So it's like a lot more infrastructure oriented than just like normal software engineering where you might be using like Java Spring or Python or like C++ to build like some kind of like front end or back end or JavaScript, whatever. It's like a lot more focused on like how does code run on machines. So before we like get into like what this talk is like actually about, there's like some room for a conversation about like how people used to deploy code to machines before. So first things first, there's this like concept of bare metal. So who here has a computer? Raise your hand. Wow, everyone has a computer. So shocking. So let's say that your computer did not have an operating system on it. That is called bare metal because like that machine is effectively just like a piece of bare metal. Like if you power it on, it might like enter some sort of boot screen and then realize there's like nothing to boot, and then it just like sits there and like blinks, right? So that's bare metal. The next logical thing is you have a computer and it has an operating system running on it. So this is a way for you to like run processes and like servers and stuff like that. Like everybody here has like a Mac or a Windows machine. Maybe some of you are running Linux. So by like a show of hands, how many like concurrent things can you run on your machine at the same time before it just becomes like incredibly slow? Like let's say I asked you to open like Chrome, some video game like Slack, and then I don't know, like another video game, right? Do you think your computer would run very quickly or very slowly? It would run very, very slowly, right? So yeah, like your computer has like a limited amount of resources, right? And when you run a lot of applications, like it becomes very, very slowly. And keep in mind, all of the applications that I listed are like single-use applications. Like only one person can use those like that thing at a time, right? Like if you're opening a video game, right? You're the only person that's like making requests to the video game on your machine. If you have like Slack, right? You are the only person like sending messages, and like you'll be gathering messages from the outside or whatever, right? But like in general, those are like single-use applications. Let's say that you're Facebook, right? If you have like one machine and like 2 billion users, right? Like odds are it's going to be very, very slow, right? Like it's like it'll crash. Like that sheer volume of requests is going to like make your like machine shit the bed. So what is the solution to like make sure that you can like engage more users or like help more or like allow more people to use your thing is to buy like more individual computers and run like operating systems on them and then run like multiple instances of your application, right? But that again is like very expensive because what is like the average cost of like a desktop computer? Say like $500, right? Let's say a computer can only run like accept requests from like 10 people before it gets like very, very slow. That's so it's like 10 people per $500. It's like $50 a user, right? It's like very, very expensive. So then someone created this thing called a virtual machine. So the way that a virtual machine works is you have like the same box, and that box is running some operating system, but it's also running something called a hypervisor, which allows you to just like split up the resources on your computer, basically like random access memory, RAM, like CPU, CPU and RAM may be the same thing, like your like hard disk space, right? And then run multiple operating systems on those things, and their resources are like localized, right? So now instead of having one machine with one operating system, you have one machine with 3 operating systems, and then you can run like applications on each of those virtual machines, and you basically like divide your cost by the number of like operating systems you can run on a machine, right? Like in this situation, it's 3, right? So it's literally like you have effectively, if you follow this like very, very vague diagram, right? Like by using a virtual machine, you would cut your costs into like thirds, right? Because now you have to buy less servers and run less operating systems on them. All you need is to buy like a third of the servers and then just run like VMs with a hypervisor. And yeah, this was like very visionary technology that was used for a very long time until this thing called containers came along. Who has heard of containers? A couple of people, wow. Who has heard of like Docker in the vein of containers? Also a couple of people. Okay. So what the idea of what a container is like a virtual machine, but like on crack. So like a virtual machine has a hypervisor that like splits the computer into like 3 distinct operating systems, or like 5 or 10 distinct operating systems, and then you can run your like applications on that, right? But like somebody who has like a Windows machine, you can like tell me, can someone like approximate like how much hard disk space like your operating system takes up on your hard drive? Thank you, Hari. Yeah, it's like 60 gigabytes, right? So that's like a lot of space, because what if you have like log files or like photos or stuff that you need to actually have on there? It like restricts your size, right? So basically what Docker it's like container, it's like I don't want to say container orchestration because that's what Kubernetes is, but it's like a way for you to like build and ship containers. So what is a container? Imagine if you had an application, right? You wrote some Python web app, and you knew exactly what like 6 things you needed to run it, right? Like you need like bash, right? You need like some sort of like terminal. You need like the Python like library to be able to run your script. You need like just some basic operating system like that plays into bash, and then you can run it, and then yada yada yada, blah blah blah, right? Like there's like a lot less things that you need. Like an operating system has a lot of like tools and utilities that like may not be absolutely like necessary for you to run your application. So what Docker does is it like strips it down all the way to like the bare minimum of like what you need, and then creates a little like virtual environment of that on your machine, using like fun little things like C groups and like other things that are like built into Linux, and then basically allows you to just like run it as a standalone. Like Docker containers are very, very, very small. and they're built on top of like base images, and you can like create a virtual environment and yada yada blah blah blah. So the nifty thing is like because it's so small, you can literally run like as many of them as your computer like will allow you to, right? So in the past, like I said, like with a virtual machine, you install the operating system, and then you install a hypervisor, and then you can install individual operating systems, right? With Docker, you install the operating system, then you install something called the Docker daemon, and then you can like set up and run as many containers as you want. So I think I have like 5 containers on there. So now you have taken, it's a fifth of the price, so it's better and faster, and so on and so forth. So containers, very cool. Strongly recommend learning about them if you have like the time and resources. Cool, so that brings us to like the actual talk, right? Building Ali Web Services, or AWS for short. Get it? Get it? Because it's like Amazon Web Services. Amazon and Ali both start with the letter A. I'm a comedy genius. Okay. So the question that is sort of like prevalent, right, is like, why do people use AWS? Why do people use Amazon Web Services, right? Like now that we understand how deploying applications works, right? Why don't people just do it themselves? Well, there's like 3 main reasons, right? Servers, like boxes, like individual machines, are expensive. An internet connection, 24/7 to multiple servers, receiving multiple requests is expensive. This also includes like power, right? Like if you have to run power to a room like 24/7, like your electricity bill will be very high. And then finally, engineers to set up, maintain, and manage an in-house data center are expensive. So like a story that I like to tell about this is one of my friends, his older brother was a site reliability engineer at Facebook, right? So like he tells me the story, and he was trying to convince me to like get into DevOps and intern in DevOps, right? He was like, dude, it's so cool. You're the most important person in the company. My brother makes so much money. He's the most important person in the company. One time he was on vacation in Cabo, and they called him up at 3 a.m. because he was the only person that could fix this problem. Doesn't that sound amazing? And I was like, no, that sounds fucking terrible. But then like I heard his salary, and I was like, wait, it sounds like less terrible. It sounds like sort of like a fair like thing to balance, right? So yeah, like some companies will be able to afford like site reliability engineers. Others, admittedly, will not, right? So like let's say that you're a student with an application, right? Or like let's say you're like a startup, right? You can't afford all of these things, right? Or yeah, let's say you're like a student with like some kind of like app that you've built that you want to like put out into the world. You can't afford all of this shit. Like you can't be like, oh, I'm just gonna buy a server and then like plug it in my bedroom and make sure that like my internet and power are like never off, like never ever 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 ever. Like your shit would not work, right? So that's why people rent from a public cloud, because you are guaranteed to have engineers that'll make sure that like the system is up 24/7. Like they do all of like the hard work of like setting it up for you. You basically just have to like give them an application or just like recreate how you set it up on your personal machine on their machine, and so on and so forth. But let's say that there was like a way for you to like get around these things, right? Setting up like an in-house data center would be like a pretty cool enterprise, right? Well, like downstairs in the hackerspace, there are like a bunch of servers, right? Like they're just like lying around. So yeah, like boxes are expensive. Well, that doesn't matter to me because Rutgers will pay for like the servers they already have. They're just like old like throwaway loaners that I can use, right? Next is like internet and power, right? 24/7 all the time. That's very expensive. But like Rutgers will pay for it because they have to keep the power on in the Hill Center all the time. And like the network downstairs in the hackerspace is LCSR's network, which is used for research, which means it's on all the time. So yeah, like cool. Power, like the individual servers, very expensive, free for me, right? Power, very expensive, free for me. And then finally, like an engineer to set up, maintain, and manage everything is like very expensive. Like cool, I have a lot of free time and I wanted to like learn. So it felt like a very like logical like thing for me to do. Cool. So there's like a general process to like setting up your own. So this is to set up like one server. If you want to set up like a data center, there's like a little bit more like involved. But basically like the steps are as follows. Like install an operating system. After you install an operating system, connect your like machine to the internet. Step 3, install Docker, and then step 4, set up something called Nginx, and then like congrats, you have a server that will be able to like let data out into the world, and like you can host a website or something, and then people will be able to use it. Very cool. So Step one for installing an operating system. Also, what time is it? So it is 5:30. I'm gonna try to get, or 6:30, sorry. I'm gonna try to get through this presentation as much as I can. If there's a little bit of time at the end, I could hypothetically do like an in-person demo of me doing this downstairs in the hackerspace. Raise your hand if that's something that would be maybe interesting to see. Too many of you raise your hand. We'll see like time permitting. If not, find me like later on, like next week or something like that. I would be happy to demo it for you. But yeah, step one, installing the operating system. Who has like ever installed a new operating system on a machine before? Just like by show of hands. Mickey, of course. A couple of other people. Cool. So like the way that you do that is you create a bootable USB with your OS of choice. So like if you have like a flash drive that's like 8 gigs or higher, that should be more than enough. You plug that into your like computer. You download this piece of software called Rufus. You download an ISO file, which is just like an image of the operating system that you want to run, and then you like drag that like ISO file into Rufus, and then you click the port in which your hard drive is running on, and then congrats, like it makes it so that like when you plug your machine, like your flash drive into a computer, you like it can either boot from that flash drive or it can just boot from the hard drive. And if you boot it from that flash drive, it takes you to a menu where you can like install everything, right? So yeah, step 2, plug it into the computer. Step 3, boot from USB instead of the internal hard drive. Step 4, go through the installer. So if you go through the installer, it's like, what version of this operating system would you like? What like extra little add-ons and features would you like? How do you connect to the internet? And then like you fill all of that stuff out, and then cool, now you have a new operating system on your machine. This is like generally very useful if you like are sick and tired of using Windows and want to like switch to Linux. That like you can totally do that. But yeah, cool. So step 1, like install an operating system on a bare metal machine or a machine that already has an operating system that is like not ideal for like server stuff. Cool. Number 2, connecting to the internet. So a brief intermission. Yeah. So there were several people here in this room when like I was like in the process of setting this up. So the rule 0 is like know how the fuck your internet is configured, because I did not, and then I was very sad. So many hours, stayed up until 3 a.m. in the hackerspace, skipped class, just trying to figure out how to connect my servers to the internet. So like the story is Rutgers has all of their IP addresses on like they're statically defined, right? So if they're statically defined, that means that you need like an actual literal number, or like 4 actual literal numbers, and then like you input those into a thing, and then congrats, your machine is connected to the internet. As opposed to something called DHCP, which is dynamic host something protocol connection. Sure, yeah. So like the DHCP is like a way for you to dynamically create an IP address, right? If you're plugged into Ethernet, it kind of like infers from context clues like what the fuck is going on, and then it's like, okay, cool, here's your arbitrary IP address. You will use this to connect to the internet. Good job, congratulations. I did not know that Rutgers was static. I just assumed that it was on DHCP. So I kind of just like was trying, like I plugged in an Ethernet port, and I'm like, this not working. Why is this not working? I'm so confused. It's 3 a.m. I should probably go home. No, it's fine. I'll figure it out. And like I kept trying to do stuff on servers that were not connected to the internet. And then eventually I just like unplugged the internet, like the Ethernet switch in the hackerspace. And then LCSR had to come down and fix the internet. And then while they were there, I was like, hey, while you're here, how do you do this? And then they like fixed it for me. But yeah, like know how your internet is set up. But yeah, cool. What's up?
What's the advantage of using a static method of getting IP?
Mickey can answer this question.
So, what basically one of the reasons why people do this is because they'll have like custom DNS like setup or whatever, or they'll have basically there's this magic file in a lot of servers called etc hosts that just tells you what IP the machine is. And it's a lot easier for sysadmins if the IPs of machines aren't constantly going all over the place. And sort of some insider information, the normal way to do this is to set up DNS, which
what is DNS, Mickey?
DNS is the domain name service. So basically, your thing would be assigned, or actually, that wouldn't exactly help. Yeah, forget everything I just said. So by having them statically assigned, they're not going all over the place. and it's a lot easier for sysadmins that need to connect to them a lot. Whereas on a home network, DHCP is easier because you don't actually care what your IP address is. You just want to connect to the internet.
Yeah. But yeah, so let's say you want to connect to the internet. Step one, plug your Ethernet cable into your machine. So when you do this, you have your Ethernet device gets a device name, or perhaps it had a device name before. I'm pretty sure that's like what's actually the case. Like if you have like an Ethernet port on your machine, then that has a device name in like the operating system. So you want to plug in the Ethernet cable, and then you want to get the device name. You can usually do that by like using some kind of like network manager, and the device name is usually typically ETH0, so Ethernet 0, or ENP1S0. So like I don't know what that means, but like memorize that pattern, I guess. So then like once you have your device name, right, you have to do two things. So, or like you can do one of two things. Number one, if you want to use DHCP, if you can use DHCP, you can literally just run like DHCP ETH0, and then it's like, oh cool, this is the Ethernet port. I can use the tool that creates a dynamic host to create a dynamic host. Cool, and then like, congrats, you have an IP address. If you can't do that, or if you don't want to, you want to like set a static IP. So there's a network config file somewhere on your operating system. It's like different for different operating systems. So like I don't have it like written down, but just Google like, where is my network configuration file, like operating system name, right? And then like you just like traverse down the Linux to get to that file, and then you edit it. And once you like open it, right, it basically will like have fields for your IP address, the gateway, the net mask, and the DNS address for the machine and its network. So IP is like your machine's address. Gateway is like the address in which like all of the internet is coming in. So like if you have a machine and a router, like your machine would be your IP address, the gateway would be the router. What is net mask, Mickey? No answer or some answer?
Oh, it has to do with like subnets.
Okay, gotcha.
So like basically like 255, 255, 255 is all ones,
Uh-huh.
and then 8 zeros. So what that means is that like your local subnet is going to be any IP where this section where the zeros can be whatever.
Mm-hmm.
But the ones has to be the same as yours.
Okay, cool. Yeah. So basically this like sets up like subnets. So if you want to like run like different applications or different like networks underneath your like address, then you can do that. Sure. What are subnets? They're just fuck off. What are subnets, Hari? That's a great question that you clearly have an answer to. Yeah, that's what I fucking thought. Talk shit one more time. See what happens.
You literally just use them to connect.
Sarah, do you have an answer?
Subnets are basically when you have just these smaller portions of a network where you can like connect things up together, but I'm not entirely sure.
Yeah, fuck you, Hari. Yeah, subnets are what she said. They're just like ways to like use like smaller parts of a network, run applications on them, like different things throughout the thing. Yeah, cool. And then finally, your DNS. Yeah.
Also, usually they are all connected to the same router.
True. This is true. Yeah, and then DNS is the domain name service. So let's say that your machine has a name. All of the servers in the hackerspace are named like HS, rack, and then a number, right? So like a DNS server, like a domain name service server, just like is basically a table where it's like, this is the IP address, this is the name. So for a server to get its name, if you give it like the DNS address, it just like sends its own like IP address to the thing, and then it gets a name back, and then it names itself that. Cool. So yeah, this is how you set up your internet. Like these 4 fields, and then like put them in a config file, and you're good. Next, setting up Docker. So this is actually very simple. You literally just install Docker. There's like lots of instructions on the internet about how to do that. More often than not, if you're on like some kind of Linux environment, it'll just be like whatever your package manager is, install Docker. So like for CentOS, which is what I use, just it's like yum install Docker. If you're using Ubuntu, then it's probably like apt get install Docker. I don't know what other Linux package managers are, but yeah. And then once Docker is installed, you just need the name of an image of an application that you particularly like, and then you will run it with some like extra flags. So if you do docker run -p 8080:8080, and then the name of the container, so like there's an application called, I don't know, like the Hackerspace dashboard, right? It's a thing that is used to like keep inventory of like who has checked hardware out of the hackerspace, right? And there's a Docker image for that. So if I do docker run -p 8080:8080 Hackerspace dashboard, Docker will literally just like go to the Docker hub and be like, oh, cool, there's an application called Hackerspace dashboard. Yoink, and then it downloads all the files to the machine, and then it runs them inside Docker, and then it does like network, like port forwarding, right? So as I said, like Docker containers environments are virtualized. So if you run a web server on a Docker container, you personally will not be able to get access to that Docker container because like it's on a like virtual environment, and you're just like, cool, I went to localhost 8080, which is allegedly where my application is running, and I cannot access it. But if you use the -p flag, then it's like, oh, cool, 8080 on like the actual machine should map to 8080 in the container. So let me just do some quick port forwarding, and then that will work. And then yeah, if you go to your home address, localhost or 127.0.0.1:8080, then your application will run there. Yes, Sarah. You can definitely SSH into containers, but like that's also absolutely not necessary because you can just exec bash inside of them. Was that what you were gonna say? Haha. Yeah, very cool. But yeah, like, so that's the other thing. Like, this is not a Docker talk. If it was, like, I would be, like, I could speak about it a lot more. But like, yeah, there's ways to like get into your container. But also like that's not necessarily useful for a web server, right? Because like even if you get into the container, like your browser is outside of the container. But yeah, cool. So then you just do some port forwarding, and then it's cool. And now the application is running on localhost of your machine, which means you can use it, which is great. And then finally, setting up Nginx. So who knows what a port is? Okay, cool. Is there a whiteboard and some markers? There's a whiteboard. Can someone please get me some markers? There's an eraser. We're like half the way there. Okay, cool. Grab me that eraser, Johnny. Thank you. Okay, cool. Okay, cool. So basically, like the easiest way to explain ports is that like your machine can like run multiple like applications and can like do many things, right? So then like those things typically tend to run on ports. So like the easiest way to visualize it is just like, here's a very large box, then like there's like a million lines or whatever, right? So this is like a table of all of like the port usage on your machine, right? So like fun fact, SSH runs on port 22. Was that correct? None of you can tell me. Awesome. Yeah. So like SSH runs on port 22. Like some other HTTP runs on port 80. HTTPS runs on port 443. HTTPS. Yeah. So basically like you have all these like things, right? And they run on these different ports. So typically web applications, like JavaScript applications tend to run on 3,000. Python applications tend to run on 5,000. It's also completely arbitrary, and you can set your like ports, right? But like what typically happens is like my app will run on like 5,000, right? Soon, like there's a lot of spots between 443 and 5,000, right? So my app runs here, right? But that means that it's running on your like local network because that's like the only place that it can serve it out to. So what Nginx does is it literally just like takes your application, which is running on this port, and then like port forwards it from like 127.0.0.1 to whatever the IP address for your like personal machine is. Let's say that that's like, I don't know, 172 point, like 168 point, like 72, whatever, right? Like some random arbitrary IP address. 172.16.6.84. Cool. Yeah, what's up?
So when you're port forwarding would you pretty much like
telling the server that this is where I want to run it.
This is where I want to run it. This is where the thing that I am, like, it kind of like works backwards, right? So when you port forward, it means that it's sort of like giving it like a notice, right? So it's like, have you taken CompArc yet?
No.
Do you know how, okay, do you vaguely understand how pointers work? Not really? Cool. Basically, like, the way that a pointer works is that when you go to some memory address, it just gives you another memory address as opposed to some value, right? So it's like, hey, do you want this thing? Actually go here. And then like your machine will go to that memory address instead, right? So it's kind of like the same thing in principle. Like your like app will go to some IP address. Nginx will store the like actual IP address of like the application that's running, and then like it'll just like you'll go there. Is that like incorrect?
I mean, the explanation I would think that I would first go to would probably be you've used a computer, so you must know what a file is. So like.
Wow.
Brilliant insight, right?
Great.
Like, I actually don't know where else to start.
10 out of 10.
Okay, so when you have a server and a client, you have somebody that is talking to your server, and you have your server, which is talking back to them, right? You need some kind of medium in order to store that information that's going back and forth, which is basically your port. Just think of your port as just like, it's a really fancy file. Like whenever something comes to you from the network, you just write that into the underlying file, and then whenever your server wants to read that, it can do that at its leisure just by reading from the file as you would from any other file. It supports the same API, if that helps. So yeah, the thing with Docker though is that Docker is its own like node in its own network. Docker is its own node in the network that has its own IP address and its own port system. So you have to port forward because your Docker container's port has to like sync up with your system's ports. Port forwarding is basically just to like kind of sync those underlying files up, which is a terribly butchered explanation, but better than.
Facts. Yeah, I've been deferring to Hari and Mickey because both of them are very, very smart. But yeah, so Nginx is like some service that allows you to forward ports. So basically, like it says up there, cool, like port forwards, right? And then So the way that you do that is you install Nginx on your machine, and then like Nginx has a config file, which you will edit. This is what you would append to the config file. So basically, you just like create a new server. You tell it to listen on a specific port. In this situation, it's port 80 because that's what HTTP runs on. And then you give it like some like bullshit to redirect to. In this case, it's like running some kind of Apache. So you're just like sending it to like the folder where Apache is like storing all of the nice little web files. Huh? This is Nginx. Even like the var/www/example.com/html. This like.
So it's Nginx config syntax, and it says Nginx in the thing.
In the thing? No, this is an Nginx config.
Yeah.
Okay, yeah. So cool. It's like some other Nginx like config, but whatever. So yeah, like you would just add some code that looks like this to your Nginx config file, and then you just like restart Nginx, and then cool, yeah. Now you have a server and it runs and it's great. Cool. So you have an at-home data center. So some notes. Number one, you can use like any computer as a server. It doesn't need to be like a rack-mounted server appliance, which like a lot of people see, or it doesn't need to be like a big thing with like 50 hard drives. You could use like a laptop, an old desktop. Maybe like you want to use a machine that's like a little bit like faster and more powerful, but not necessary. And then it's like pretty simple to do. It takes like 4 steps, and then you learn a skill that is like not that prevalent in the industry, and then a little bit more tactile and hands-on than just like writing code. Like not that many people know DevOps stuff. Like if you walk into like a decent amount of like tech company offices, like, and you ask someone, hey, how does your code get deployed? Like most people are like, this is the DevOps guys. Like it's becoming like a little bit more commonplace that like software engineers have a little bit of like a DevOps experience. But like for the most part, like it's sort of like a completely different subset. And like in doing something like this, you learn a completely different subset that makes you more hireable, but also is like just generally very cool. So then like the question comes like, what do you do after you've done this stuff? Set up Kubernetes, and then you can make multiple like servers communicate with each other. So Kubernetes is like, if Docker is for creating containers, Kubernetes is for orchestrating containers. So basically, it's like a way for you to like run multiple different Docker containers on different machines through the use of a kube master and a kube worker. So then you'll have like 9 workers and like 1 master, and then the master will be like, hey, you container, run on box number 7 and run this many instances of the container. So that way, like, we can do some like fault tolerance and like load balancing. So like people don't fucking like crash the single Docker container that we're running on the single machine. And then number 2, set up some kind of like continuous development, continuous integration pipeline with like Chef or what's the other one, Jenkins. So basically, like continuous development, continuous integration means that like, so backing up a little bit. So Docker, when you create a container, you're actually creating an image of that container, passing the image to the Docker daemon, and then the Docker daemon like interprets that and is like, okay, cool, I know what's going on, and then it like runs it, right? But let's say that like you change your application a little bit. That means that you have to build a new image, and then once you build a new image, like you send that to Docker. But let's say that your like application is like constantly rolling out like updates. That means you'll have to be manually rebuilding your Docker container every single time, which is like somewhat tedious and like not necessarily what you want when you were like maintaining some kind of application that goes out to the world, right? So continuous development, continuous integration, like just like tracks changes, and then you like give it multiple steps in the process of what it should do, and then it's like cool, yada yada yada. Wonderful. Like now there's a new Docker image of it, and then you don't really have to touch it. So that's very cool. Also, like once you've done this, you should set up some kind of like web dashboard that like deploys like instantly. So who here has used AWS before? Couple of exactly 3 hands. So when you use AWS, right? It's not like they give you, and it's not like you call someone at Amazon and they're like, hey, cool, here's an IP address for your machine, good luck. There's like a little web dashboard, and then you like specify all of the things that you want to do, and then you create like your EC2 instance, right? Like they put you on a specific box, and then you can SSH into that and like mess around and do whatever, right? So like instead of you having to like physically sit down at a machine that's like plugged in and then like install Docker, this, that, the other thing, like just create like a web application that like communicates and can like run code on your like physical box, and then ta-da, cool, it works. Phenomenal. This guy, has anybody watched HBO's Silicon Valley? Cool, that's John from Maliant. It's the reference, strongly recommend it. Cool, and then there's like a brief epilogue. Hello, hi, I'm a human being, and I go to a lot of hackathons, and like in my time as like president of USACS and like just a person at Rutgers, I've seen a lot of people build like really cool stuff, right? But like as someone who usually does not have more than like $30 in his checking account, I can like totally understand why hosting your web application or like your like machine learning project on AWS is very expensive. Like because AWS in and of itself is very expensive. They charge you for like the time and then like also for traffic. So one time I like just put up a thing to test it, and then I forgot to take it down, and then the next month Amazon was like, you owe us $50, and I was like, I don't have $50. They suspended my Amazon account because I never paid them, my entire Amazon account, because the card on that account was an old card. So then they were like, this doesn't exist, pay us the money you owe us, pay us now. And then I never did, and now I can't use AWS anymore. Haha, very cool. What's up?
I got my account temporarily suspended over 50 cents.
Yeah, there you go. Like, yeah, like just like outside of all of like the politics of like billionaires are bad and shouldn't exist, right? Like it's just like it's hard for students who usually do not have like a lot of money to run cool shit, right? So like in building this project, I wanted to give like students at Rutgers a place for them to put their projects if they wanted to, because like hosting is expensive and it should like hypothetically be free. And I hope that like this thing that exists downstairs in the hackerspace like keeps people building cool shit. That being said, like if any of you have projects that you have built and are proud of and want like other Rutgers students to use, let me know and I'll throw it up on AWS. Cool. That's the entire presentation. Hello, thank you. Aw, cute. Okay, we have about like 10 minutes, so if anybody would like to ask any questions, I would like to answer them. And then if there's definitely not enough time for a demo because installing an operating system takes more than 10 minutes. But yeah, what's up?
So what sort of stuff is available for people to use today, and how can people get involved
In what?
in like doing stuff with Ali Web Services?
In doing stuff with Ali Web Services. So like if you learn Docker and create a Docker image of your application, I will manually edit the config file for Nginx and then run your application on a Docker container, and then Rutgers students will be allowed to use it. So yeah, like the IP address that we have like only serves out to the Rutgers network, which hypothetically for like any student project should be enough, at least at the beginning. Eventually we will get like a public IP address, and then we'll be able to like, eventually we'll be able to like run it on like Wild West, as the people at LCSR call it. And then you'll be able to like access that stuff. But yeah, like it's like pretty small. We're like, me and some of my friends are working on like adding more cool features. Like the web dashboard doesn't exist yet, so we're working on building that so that people can just like request server space. We're working on building a CDN, or content delivery network. So like we just have like a very, very large box that has like 5 terabytes of space. So like instead of like hosting images and stuff like that onto like a physical box, we can just host that on the CDN, and then like the internal requests will work. And then like probably create like a meme store or something like that. Pretty cool. But yeah, like there's not that much that exists to be used, but like it's a work in progress, and what we have now is definitely enough to accommodate like a bunch of students. Any other questions? Yeah.
So is this something like you store like your website on, or like you upload your website to, so then Rutgers students can access that website?
Yeah, basically. That's yeah.
Like locally? Okay.
Yeah. Off of RU Wireless or RU Wireless Secure. Cool. Any other questions? Was there anything that was like unclear in the presentation? Yeah, Hari? Why are you wasting my time? I'm kidding. What's up?
Okay, yeah, anyway, what's in the future? If everything goes according to plan, what kind of interface would students have to deploy their apps?
It would just be a pretty simple website. You would just like link to your Docker image on Docker Hub. And then like we would probably do some like validation, and then like manually.
No, I'm asking. Like,
No, so like the web application will exist. Like we'll get like a list of requests of all of the different like Docker images. We'll probably like open them up, look at the source code, and then if that's okay, like from our end, we would be able to like push a button, and then once that button is pushed, like Ansible or some other orchestration software will just like run the thing and like send a request to Kubernetes. Like it's not that much work. It's just this semester I'm taking a lot of credits, and also I waste a lot of time. Any other questions? Anything? Any other remarks in general? No. Well, oh yeah, cool.
You're a smart person.
Oh, thank you. It was very kind. Cool. I don't know how to respond to that, but like, thank you, obviously. Anything else? We have five minutes. Cool. If you've never stayed around, so like this concludes the Hacker Hour. Thank you all for coming.